I'm leaving the first few seconds so that you can take a screenshot and use it as the notes. So I'm leaving the first few seconds to reduce the effort that you have been putting. You can take a screenshot and get that printed out so that there is no need to write the things. So it will be an easier way. Okay, let's move on to curtius rearrangement. I want to speak about two rearrangements. One is curtius and the other one is Lossen rearrangement. So these two rearrangements are quite important. They are similar to Schmidt reaction. So I'm taking acid halide and making it react with sodium azide. So this is N3. We have previously reacted with HN3. This is NaN3, sodium azide. So when you take sodium azide, it is Na plus and N3 minus. So this is the N3 minus. So it is similar to a nucleophile. So the N3 minus attacks the carbonyl carbon of the acid halide and the Cl minus ion leaves. So the Cl minus along with the Na plus will leave out as NaCl. So the N minus attacking here on the carbonyl carbon. So nitrogen is forming a bond as a result. So what I can say is nitrogen, all the nitrogen has a lone pair. Every nitrogen has a lone pair except this one. So it is forming a bond, Cl minus being replaced by this nitrogen. And after that we know that N2 is a good leaving group. So nitrogen is leaving out as N2. And this bond, this nitrogen, this negative charge on the resonating structure of azide ion is shifting in this direction. Why? Because when this group leaves, what is the charge formed on this? Positive charge, and positive charge on nitrogen is not really stable. So immediately what happens? The alkyl group that is present here shifts onto this nitrogen atom. Otherwise it would have become electron deficient. So this alkyl shifts onto this nitrogen atom because N2 gas has left. As a result of which what happens? There forms a positive charge on this carbon. And to nullify the positive charge on this carbon, this negative charge that is present shifts onto this carbon atom. That is, it forms a double bond. So as a result of which we are forming, this group is nothing but isocyanate group. And we are very much familiar with isocyanate, which we have already seen in Schmidt reaction. Isocyanate, as you know, on hydrolysis will form RNH2 and CO2. I have explained the hydrolysis reaction of isocyanate in the previous videos. So what happens is H plus gets attacked here, OH minus gets attacked here, one bond breaks, second H and second OH, the second bond breaks, you are left out with RNH2 and this becomes the CO2 part. Similarly, the next rearrangement reaction is Lossen rearrangement. So in this rearrangement, the process is similar because we are forming an isocyanate still, but here the compound that we are taking is an ester of hydroxamic acid. So I'll guide you through this. So what is RC double bond or NHOH, that is hydroxyl group. We know NH2OH is a hydroxyl group. Instead of that you are having an ester group. So what you are having is RC double bond O group. So this is the ester of the hydroxamic acid. When you take this compound and make it react in the presence of a base, I think we can easily identify that this hydrogen is the acidic hydrogen. Or OH minus can abstract this hydrogen very easily. So let us go into the mechanism of it. OH minus abstracts this hydrogen, as a result of which a negative charge is produced here. If you recollect, this is something similar to an enol. So it is similar to an enolate group. So this negative charge that is present shifts onto this and immediately it shifts here, and this O group that is present will leave out as an ester molecule. So what finally happens on this? The isocyanate group is produced. I think you can see that. The isocyanate group is produced. How I am showing it? The negative charge shifts on this direction. During the process, the ester group is leaving. Once the ester group is leaving, there would have been a positive charge on nitrogen, which is not really stable. Electron deficient nitrogen would have been formed. So immediately an alkyl group shifts in this direction. So I should write it like this. Immediately an alkyl group shifts in this direction. The ester group leaves and the negative charge on this will shift onto this, form a double bond, because the moment the alkyl group leaves, what charge is formed? A positive charge is formed. So if a positive charge is formed, to nullify the positive charge, the negative charge on the nitrogen atom forms a double bond. That is what we have seen in curtius rearrangement also. The alkyl group is shifting on to the electron deficient nitrogen. Here the alkyl group is shifting on to the electron deficient nitrogen because the ester group is leaving. So immediately the result of this is an isocyanate which on hydrolysis will forms an amine and a CO2 group. So that reaction is Lossen rearrangement.